All right, this is the problem you've been looking for, the last one in this series of videos. So, this one is, well, just read it. Pause it, try it on your own. You're looking out the window of your hotel room at a building about 70 feet from the hotel. You note the angle of elevation to the top of the building is 40 degrees and the angle of depression to the bottom of the building is 16 degrees. How tall is the other building? Oops. All right, so this is a lot, and it's a lot to think through. Read it a few times if you need to. Recognize that you're looking out a window, and you've got an angle of elevation. So from the horizon up is 40 degrees, and an angle of depression down, which is 16 degrees. So what does that mean? That means this building over here, across the street, and you are in this building over here. All right, so that's not a very good picture, so I'm going to draw it again. Oh, I did not want to do that. So I've got two buildings, one here, and I'm in this building. I'm looking across the street at another hotel building, and that angle of elevation is 40 degrees. And then I'm looking down at the bottom of the building. I don't like that. And that's 16 degrees. I don't like this either because my 40 degree angle is smaller than my 16. Maybe you're alright with it and could live with it. I'm going to try again. I'm going to put my little guy down here. That way when I look across the street at the bottom of the building, that angle is smaller. When I look at that angle is going to be bigger. And now this building, something like this. And so, how tall is the building? So, wow, that was a lot of work just to get the picture, but it's pretty important. So this is 40 degrees, this is 16 degrees. We need to know h, the height. We know the hotel room at the building. Your hotel is about 70 feet from the other hotel. So this is 70 feet. So how are we going to do this? Pause it and look at it. Think it through. You know what you can do. You have the fundamentals. Hopefully you're seeing two right triangles here. Hopefully you're realizing, hey, I could find x, I could find y, and if I know x and y, I can add them together to get the height. And that's all we're going to do. So we're going to take a look. We know the angle here. Puzzled why that's not working. But we're going to find the angle. We have this side and this side. This is the hypotenuse. This is opposite and adjacent. So if this is opposite and adjacent, hopefully you're thinking tangent of 40 degrees equals opposite x over 70. Tangent of 16 degrees equals y over 70. See, again, this is opposite, this is adjacent for this triangle. And then we can cross multiply and divide and solve here and get x equals 70 tan 40 and y equals 70 tan 16. And I haven't calculated those. So 70 tan 40, 58.7. And then 70 tan 16, 20.1. We then know that the height of the building is going to be 58.7 plus 20.1. So the height is 78.8 feet tall. So really the picture is the hard part. And you saw the process I went through of kind of sketching it out, and I even drew it, and I didn't like it, so I started over and I drew it with him lower, so this angle was bigger. Putting the 70 feet between the buildings and the two angles in, setting up tangent because I have the opposite and adjacent sides in both cases, finding x and y, and then adding them together to get